So, today we're going to look at finding the percent increase or decrease, which is the same as finding the growth rate. And I believe you guys have looked at this prior to now. Growth rate is equal to a new population minus an old population divided by the old.
Move it down a little bit.
It's not always populations that we're looking at. Sometimes we'll be looking at values of a car, an art piece, a bank account. But right now we're just looking at skeeters and their populations. So when things are given to you in a list, this first one would be the old and the second one would be the new.
Would the old always go first?
Yes. So we have 5 minus 1 divided by 5. Sorry, divided by 1. I lied. So what's 5 minus 1?
4.
Over 1, which gives us...
4.
This is a decimal. When we determine these values, they're given to us as decimals. And we need to change it to a percent. So we need to move our decimal. How many places?
1 to the right.
No.
2 more.
Annie?
Oh, I was gonna ask a question.
Go ahead.
So is the one on the right always the new?
Yes. Yes.
To the right.
2 to the right.
Does it?
Decimal places right there.
Does that like how many we move it to depend on how many numbers there are?
Nope. It's a rule because you're multiplying by 100.
So it's always,
You always move it 2 places.
so it's 400 now.
It is 400%.
So we're finding percents.
Yes. Finding the percent increase or decrease. Okay? So for B, we have old and new. So we have 333 minus 325 divided by 325. So 333 minus 325 gives us 8 over 325.
40.625.
0.0246. You do 8 divided by
So what is that as a percent?
2.4%.
2.4%. C, we have old and new. So we have 5,000 minus 5,255 divided by 5,255. So what do we have in the numerator?
No,
It's a negative. Negative 200.
Okay, divided by 5,255.
4999.
What does it say on your calculator?
4,000.
Yeah. Negative 255.
So it's negative 25.
Negative
.048.
Negative 0.048.
Which is what as a percent?
Negative 48.
And negative is implying what?
Decreases.
A decrease. Very good. And sometimes it happens when we buy a vehicle, the value of the vehicle decreases. When you purchase a house, you hope that the value of the house increases. That doesn't always happen. When you put money in a savings account or stocks, retirement account, you're hoping that your money increases as well.
Isn't that interest? That would be nice.
Yes. All right, now we have a table. We have years and skeeters, and we need to find the percent change. So we need to compare 2 years in order to find percent change. So this very first box here, we don't have anything to compare it from the previous, so there's no percent change there. So now when we're in the second row, we can compare years 0 and 1. So in comparing years 0 and 1, which number would represent the new Skeeter population?
1. Or no, 0.
7 minus 5.
Wait, what? Oh.
Skeeters. This is years. These are Skeeters. So we're not going to compare years. We're comparing the number of Skeeters.
Okay.
And we divide that by.
5.
So 7 minus 5 is?
2.
2 divided by 5 is? No.
That's what I got.
2 divided by 5 is
0.4.
0.4, which is what percent?
40%.
Okay. So in comparing years 1 and 2,
You would do
11
11 minus 7 divided by 7.
no.
Or divided by 11.
Yes. New minus old divided by old, so it is.
Wait a second. I just. Power?
4 divided by 7, which is?
0.57.
Which is?
57%.
Okay.
It's all making sense to me now.
All right, we have to complete the following table and the graph. Now, when we've been looking at this the past couple of days, X has been representing the what?
The years.
The years or the? What have we been doing? What have we been doing with Pizza Box?
Shakes.
Shake.
Oh, shakes and skittles.
And what has been represented on the y-axis?
Skate as in the skittles.
Skeeters and like volume.
The exact same thing.
Another bacteria.
Yeah, I could get salmonella from that.
All right, we have our X values are given to us. We need to determine Y. So we need to substitute the values of X into the equation. So this is 5.
0.
No.
5.
No.
Wait, I just said 5 zeros. That's like what the. No, that's what the thing would be.
It'd be what?
1.
1.
What?
Because there's 1 0. Because the exponent, right?
Yes.
That's so beautiful.
I don't like that.
5 to the first power is?
5. 25.
5 to the second power is? 5 to the third power?
No idea.
125.
Yes. 5 to the fourth power?
Good question. I don't know.
It's too big.
5 times 5.
Too big.
Times 5. 625.
Okay. And 5 to the fifth power?
3,125.
She knows.
Hey, quick question. I don't get the whole 0 exponent thing.
Anything raised to the 0 power is 1.
Alright,
Why?
thank you.
Wait, why though?
Just because of it.
Just because I
because
said
of
so.
So go with it.
Okay?
I'll accept it for now.
Okay. If you have, I could tell you, 5 squared over 5 squared. Lauren.
25 by 25.
5 squared over 5 squared. If we simplify this, what value does it give us?
1.
1. And this is the same thing as 5 to the 0 power.
That's 2. Okay, yeah, okay.
I just
Whatever,
like
I'll
what you
accept
said,
it.
so
I'll
I like
accept
that
it.
explanation.
You'll actually get into the rules of exponents next year in Ag 2 because it's what we're covering right now. But that is why anything raised to the 0 power is 1 because it's taking something raised to the power and dividing it by that same something and raising it to the same power. And it simplifies to 1. All right, we need to go up to what value on the x-axis?
5.
5.
All right, I'm going to skip
0.
every other. And up to what on the y?
3,001.
Alright, so I don't really want to go to 3,000.
Neither do
So what's the next value?
625.
Alright, so we can do increments of what? 50s, okay?
Oh, I can't see the drawing.
You skip lines?
I am.
Your hand's a bit in the way.
Just going up by hundreds, Lord.
I was going up by hundreds.
I did 50s, I just skipped where the 50s would be.
Let's see what you do.
That's smart.
I'll ponder that for a moment.
Alright, so at 0 we have
1.
1.
That's way low.
At 1 we have
5.
5.
At 2 we have
25.
at 3 we have
125.
at 4 we have
625.
Who's the one? 5 is on the scale.
So is this giving us a line?
Yes.
Curve. It's curved.
It's curved like a slide.
Is this a function?
No, because it's good.
No.
Function says for every x there's one y.
Oh,
So is the x repeating?
No.
Is it passing the vertical line test?
But no.
Vertical line test.
Yes.
Oh, yeah.
It is passing
Oh,
the
yeah,
vertical
that's
line
all.
test.
Eyes. Oh.
Remember when you draw a vertical line, is it just hitting it in one spot? So yes, it is a function because
For every x, there's what?
there's one y. For every x, there's there's one y. And it passes the vertical line test. Example 3. Write the following in exponential form.
2 to the 3rd times 3 to the 2nd times x to the 2nd times what?
Genius.
Can I write y to the first?
Yeah.
Good.
Do I have to?
No.
It's
It's
a little
implied.
hard to say.
It is implied. Example 4. What do I have?
5 times 5 times 5 times 7 times 7 times 5 x's.
Yes.